There is a planet in our solar system where winds move faster than a speeding bullet, where it rains diamonds by the millions, and where a doomed moon is slowly spiraling toward its own destruction. And almost nobody is talking about it. Neptune is not the biggest planet. It is not the prettiest. But by almost every measure of raw, hostile power, it is the most terrifying world our solar system has ever produced. And the more scientists study it, the less they understand it. This is a planet that should not exist. Not the way it does, not with those winds, not with that heat, not with those storms. And yet there it sits, 2.7 billion miles from Earth, spinning silently in the dark, daring us to come closer. Let's talk about what's actually out there. Start with the winds, because nothing else on this planet makes sense until you understand what the atmosphere is doing. Neptune's winds reach speeds of 1,200 miles per hour. Some gusts push past 1,500. That is not a typo. That is not an exaggeration. 1,200 miles per hour. The fastest winds ever recorded on Earth hit around 250 miles per hour during the most extreme hurricanes. Storms powerful enough to level cities, tear roofs off buildings, and push walls of seawater inland for miles. Neptune's slowest winds are nearly 5 times faster than that. Its strongest gusts move at roughly 1.5 times the speed of sound. Think about what that means for a moment. On Neptune, the wind itself breaks the sound barrier. And here is the thing that should haunt you. Nobody knows why. Neptune is the farthest major planet from the Sun. It receives almost no solar energy, about 900 times less than Earth does. The Sun, from Neptune's surface, looks like nothing more than a very bright star. There is barely any heat driving the atmosphere. By every law of physics we understand, Neptune should be calm, frozen, still. Instead, it is the windiest place in the entire solar system, more violent than Jupiter, more violent than Saturn, more violent than anything we have ever found. Something inside this planet is generating energy we cannot account for, and it is feeding those winds with a fury that makes no sense at all. Which brings us to the temperature. Neptune's average atmospheric temperature sits at around negative 330 degrees Fahrenheit. That is colder than liquid nitrogen. Cold enough that the methane gas in the upper atmosphere literally freezes into clouds of ice crystals, blue-tinged and razor-sharp, being flung across the planet at bullet speed. It is a world where the air itself is a weapon. But step back for a second. Because cold and wind alone do not make Neptune unique. What makes Neptune truly terrifying is what is happening deep beneath those frozen clouds, in the darkness miles below the visible surface. Methane. The planet's atmosphere is loaded with it, roughly 3% of the total composition, and under normal conditions methane is just a gas, odorless, colorless, unremarkable. But push it deep enough into the planet where pressures reach 1 million times Earth's atmospheric pressure, where temperatures spike to tens of thousands of degrees Fahrenheit, and something extraordinary begins to happen. The methane molecules crack apart under the strain, the carbon atoms are stripped free, and then, under that incomprehensible pressure, those carbon atoms find each other. They bond, they compress, they crystallize. It rains diamonds on Neptune. Not metaphorically, not theoretically. Scientists at the Lawrence Livermore National Laboratory and Stanford's SLAC facility recreated these conditions in the lab, firing powerful lasers into hydrocarbon samples to simulate Neptune's interior, and they watched it happen in real time. The carbon crystallized into diamond structures just as predicted. On Neptune, researchers believe diamonds form continuously in the interior, millions of carats worth, sinking slowly through the planet's ice layers and accumulating in a vast glittering shell around the core. The diamonds may grow enormous. Some models suggest individual stones millions of carats in weight. There is right now more diamond on Neptune than there is on any other body in the known solar system by an almost unimaginable margin. It is the most valuable place in the solar system, and also one of the most unreachable. Now here is something that will stay with you. When Voyager 2, the only spacecraft that has ever visited Neptune, passing within 3,000 miles of its cloud tops on August 25, 1989, sent back its first detailed images, scientists saw something they had not expected. A massive dark storm system, enormous enough to swallow the entire Earth, rotating counterclockwise in Neptune's southern hemisphere. They called it the Great Dark Spot. It looked like Jupiter's Great Red Spot, that ancient permanent storm that has raged for hundreds of years. Scientists assumed Neptune's Great Dark Spot was the same kind of structure, a permanent feature, a defining characteristic of the planet. 5 years later, the Hubble Space Telescope looked at Neptune again. The Great Dark Spot was gone, completely, without a trace. And in its place, new dark spots had appeared in the northern hemisphere. Neptune's storms are not permanent. They form. They grow to planetary scale. They rage with winds exceeding 1,300 miles per hour. And then they simply dissolve, leaving behind no evidence that they were ever there. Scientists still do not fully understand how a storm the size of Earth can just vanish. It is one of the deepest unsolved mysteries in planetary science. But Neptune was full of mysteries long before anyone ever saw it. In the early 1800s, astronomers had noticed something wrong with Uranus. The planet was drifting, slightly but measurably, off its predicted orbital path. Something was pulling it. Some unseen gravitational force was tugging at Uranus from the outer solar system. At the time, no one knew what it was. Then, in 1845 and 1846, two mathematicians working completely independently, a British astronomer named John Couch Adams and a French mathematician named Urbain Le Verrier, sat down with nothing but paper, pencils, and the laws of gravity, and calculated exactly where an undiscovered planet must be to produce that gravitational effect. They had never seen the planet. No telescope had ever pointed at it. They worked purely from numbers. Le Verrier sent his calculations to the Berlin Observatory. The astronomer Johann Galle trained the telescope on Le Verrier's predicted coordinates on the night of September 23, 1846. He found Neptune within 1 degree of where the math said it would be. A planet was discovered by pure mathematics before it was ever seen by human eyes. That had never happened before in the history of astronomy. And when you sit with that for a moment, the idea that the human mind could reach 2.7 billion miles into space using nothing but equations and logic, it is one of the most extraordinary things our species has ever done. Neptune was not found. It was calculated. And yet, even after its discovery, Neptune has spent 180 years confounding every scientist who has studied it. Take the magnetic field. Every planet with a magnetic field generates it through motion in a conducting layer deep in the interior, molten iron in Earth's case. Earth's magnetic field is tilted about 11 degrees off the planet's rotation axis. That is a small offset, and it produces the north and south poles we can navigate by. Neptune's magnetic field is tilted 47 degrees off its rotation axis, nearly halfway to perpendicular. And it does not even pass through the center of the planet. It is offset from the core by more than half the planet's radius, as if the generator is sitting in completely the wrong place. The result is a magnetosphere that does not rotate like a normal planetary field. It tumbles and flips and gyrates with every rotation of the planet, sweeping through space in a wild, chaotic pattern unlike anything else in the solar system. Scientists believe it may be generated by a thin shell of electrically conducting fluid, a mixture of water, ammonia, and methane deep in the mantle, rather than by a metallic core. But the full explanation still eludes us. And then there is the heat. This is the mystery that troubles planetary scientists the most. Every planet receives heat from the sun, and every planet radiates some of that heat back into space. The math should more or less balance. But Neptune emits roughly 2.5 times more heat than it receives from the sun. 2.5 times. There is a furnace inside that planet that is generating tremendous amounts of thermal energy, and we do not know what it is. Gravitational contraction from the planet's formation billions of years ago is one possibility. Radioactive decay in the core is another. Atmospheric interactions with the magnetic field. Gravity waves from the interior. Every candidate theory has serious problems, and none of them fully accounts for the numbers. Neptune is producing heat that has no verified source. A planet this far from its star should be dead, frozen through and through, with barely enough energy to sustain a whisper of atmospheric movement. Instead, it is raging. And the strangest chapter of Neptune's story may belong not to the planet itself, but to the moon that circles it. Triton is Neptune's largest moon. It is enormous, roughly the size of Pluto, with a surface covered in nitrogen ice that makes it one of the coldest places in the solar system, with temperatures around -391 degrees Fahrenheit. Voyager 2's cameras caught geysers of nitrogen gas erupting from Triton's surface, shooting dark plumes miles into the thin atmosphere. On a world that cold, there are active geysers. Active, not dormant, erupting. But Triton's most disturbing feature is not what it does, it is what it is. Every large moon in the solar system orbits in the same direction as its planet rotates. That is the rule, a consequence of how moons form from the same rotating disk of material as the planet itself. Triton breaks that rule completely. Triton orbits Neptune backwards, in the opposite direction of the planet's rotation. It is the only large moon in the entire solar system to do this. There is only one explanation. Triton did not form alongside Neptune. It was something else, something from the outer solar system, a dwarf planet wandering through the Kuiper Belt billions of years ago, that came too close to Neptune and got captured. Neptune's gravity reached out and snatched it, and whatever companion object Triton had been traveling with was flung into deep space, never to return. But Triton's story does not end with capture. Because of its backwards orbit, tidal forces between Neptune and Triton are pulling the moon inward. Every orbit, Triton falls slightly closer to Neptune. The gap narrows, slowly, relentlessly, over billions of years. Scientists calculate that in about 3.6 billion years, Triton will cross what is called the Roche limit, the distance at which Neptune's tidal forces will be stronger than the gravity holding Triton together. At that point, the moon will be torn apart, ripped into fragments that will spread into a vast ring system around Neptune. or simply rain down onto the planet in a catastrophic impact. Either way, Triton is already dead. It just doesn't know it yet. The countdown is running. And here is the final weight of all of this. We have visited Neptune exactly once. One spacecraft, one flyby, 6 hours of closest approach, and in those 6 hours in 1989, Voyager 2 sent back enough data to keep scientists puzzled for decades. The winds we cannot explain, the heat we cannot source, the magnetic field we cannot fully model, the storms that appear and vanish, the diamond interior we cannot reach, the doomed moon falling to its destruction in geological slow motion. There are missions being discussed, concepts for a Neptune orbiter that could spend years studying the planet up close, but as of now, none have been approved, none have launched, and none are on their way. Neptune sits at the edge of our solar system, 2.7 billion miles out, doing things we do not understand, with a fury we cannot survive, powered by something we cannot identify. It is not the biggest planet we have found, it is not the most talked about, but if you are looking for the place in our solar system that represents the full terrifying scale of what nature is capable of, the place where the physics get strange, where storms eat worlds and die without a trace, where moons fall in slow-motion catastrophe toward their end, where it rains diamonds and nobody knows why the lights are still on, it is Neptune. It has always been Neptune. So here's what I want to know. Which part of Neptune's story got to you the most? The diamond rain? Triton's slow-motion death? The fact that we found an entire planet using nothing but math? Drop your answer in the comments, because this is one of those conversations worth having. If this blew your mind, hit that like button and share it with someone who thinks they know everything about space. I promise they don't know half of this. And make sure you're subscribed, because next time we're going somewhere even stranger, a place where the rules of physics break down in ways that make Neptune look perfectly ordinary.